wanting to try to figure out how to use it, and I'm trying to look at it from more of a physics scientific perspective. So this is the lever arm, or the actuator, that goes into the device. And this one has 96 increments. So the question is, how precise can we be when we're rotating the mineral to create the facets in the process of turning the stone into a gem? So what we do is we take the number of increments, which is 96, and we know there's 360 degrees in a circle. So to determine the increment size, we take the 360 divided by 96, and we know that the increment in degrees is 3.75 degrees. Well, what's that mean? Well, our precision is half the smallest increment. So that is 1.875. And since precision and the uncertainty is at most two significant figures, it's 1.9 degrees, or approximately 2. But how does this work when we're, or how does the, in other words, how does this affect the faceting process? So here we have a crystal picked up at the mineral shop. I've already gone through and kind of flattened the edges, and I want to determine what are all the angles of these edges. So what I did is I went through and I took the crystal, lined it up on the edge of my graph paper, held it tight, and traced all the edges. Oop. For something like that. So there's a lot of different kinds of compasses out there. Here we've got a nice high-end compass, and then I had run out of lead, so I got a cheap compass. And what's the difference? In the process of trying to do this with a cheap compass, what I found is that as I was trying to use it, the plastic would flex, which would increase the uncertainty. So how do you go about measuring what these angles are? So what I did was I took and lined up the compass on each end to create an arc, and then lined up the compass at the other point to create another arc, and then increase the distance, draw another arc, increase the distance, draw another arc, then take a protractor, line up the cross points, to draw the perpendicular, and that's the bisector. But I'm being pretty careless, as I'm just trying to demonstrate the technique. So from here you can repeat and repeat and repeat, and I got basically this. So the interesting thing that is, the farther you go out, the more difficult it is to determine where the intersection point is. Had I been able to use this document camera, I would have been able to get a slightly better job. But here are my facet angles, and I used a point here for the 0, and I came up with these angles. It's like, but that was the first step. So it's like, okay, I've got all those facet angles, but how does that relate to my precision? So here are my facet angles. I go, I want to set the first one to 0, so I'm going to subtract off the 28.5 from each subsequent angle measurement to come up with something that's calibrated with a reference to 0. So facet angles, I subtract out 28 to get up these, but I know based upon a six-sided hexagram, these are what the angles are supposed to be. So what is the difference between the cut angle and the ideal cut angle? So the difference, 63.5 minus 60 gives me 3.5. Go on and do the subtraction, and so this is the difference between my measured angle and what I wanted, or what was supposed to have been cut. So 3.5, 3.5, 5, 7.5, 6. So I want to minimize, that way I have in my uncertainty, in other words, get these closer around to 0, that way I get the plus or minus. So I do subtract off 3.5 from this, that way I have the above and below numbers. So this is minus 3.5 plus 2.5, 3.0, 2.0. I could try to center these differences around a line, but that's a bit too much work. We go back to the precision of the device, and it's plus or minus 2, and we have plus or minus 3.5. So that is how the precision of 1.9 corresponds to the precision of how this particular crystal was faceted. So this looks like it's plus or minus 3.2, which is kind of close to the 1.9. So on the gem diagrams, you have different wheels with a different number of increments, and that's going to correlate to how precise can you get the cut angles to the ideal angles.